Hello children, before moving ahead, we need to learn differentiation and integration as they will help in solving several numericals in physics. So let us start with differentiation. The first question is why to study differential calculus? The purpose of differential calculus is to study the increase or decrease in a quantity with respect to another quantity on which it depends, varies independently. So let us understand what does this statement mean. Consider a particle is moving along this curve in 2D Cartesian coordinate plane. At any moment, its position is given by two variables known as coordinates. X is independent variable and y is dependent variable. Value of y depends on x and it is given by y is equal to function of x. For each and every value of x, there will be a unique y. So in differential calculus, we study how the value of y varies when x varies independently. Now let us see two important terms. First one is average rate of change. Consider 2 points A and B whose coordinates are x1 y1 and x2 y2. So average rate of change is defined as average rate of change in y with respect to x in this interval x1 to x2, and it is given as change in y upon change in x, that is y2 minus y1 minus y1 upon x2 minus x2 minus x1, and that is equal to delta y upon delta x. This is delta y, this is delta x, and that is equal to slope of chord AB. Second term is instantaneous rate of change. Consider delta to be very small so that this interval shrinks to a point x. Then instantaneous rate of change is given by dy by dx and it is equal to tan theta, where theta is the angle that tangent at P makes with the positive x-axis. Dy by dx can be calculated by first derivative of function y is equal to fx, and it is denoted by dy by dx is equal to y dash is equal to f dash x. Second order derivative can be written as d square y upon dx square is equal to y double dash is equal to f double dash x. Similarly, we can write higher order derivatives. Second order derivative onwards is called as higher order derivatives. Let us see first derivatives of commonly used functions. First one is y is equal to k, where k is a constant. So dy by dx is equal to 0. Second one, y is equal to x to power n. dy by dx is equal to n x to power n minus 1. It is easy to remember, put n here and reduce the power of x by 1. So it will be n x to power n minus 1. Third one, y is equal to e to power x, exponential function. dy by dx is e to power x, same, no change. Y is equal to ln x. ln is natural log on the base e. So dy by dx is 1 by x. Fifth one, y is equal to sin x. Now here onwards, all the trigonometric functions. Y is equal to sin x. So dy by dx is cos x. Y is equal to cos x. dy by dx is equal to minus sin x. Y is equal to tan x. dy by dx is sec square x. Y is equal to cot x. dy by dx is minus cosec square x. Y is equal to sec x. dy by dx is equal to sec x tan x. Y is equal to cosec x, dy by dx is equal to minus cosec x cot x. You may note down the table and memorize it. Now let us see rules for differentiation. First one is, if function is multiplied by a constant y is equal to k times fx, then y dash will be k times f dash x. Means you have to take the derivative of the function and multiply with the constant. Let us see this example. Y is equal to 2x square. Then y dash will be equal to 2 times of, let us take the derivative of this function, d by dx of x square. You know that d by dx of x to power n is equal to n x to power n minus 1. Here n is equal to 2. So y dash is equal to 2 into n, means 2 x to power n minus 1 means x to power 2 minus 1, and that is equal to 2 into 2, 4 into x to power 2 minus 1, that is 1. So y dash is equal to 4x. Second one is addition or subtraction of two functions. We will see addition first. Y is equal to fx plus gx. Fx and gx are two functions. So y dash will be equal to f dash x plus g dash x. Means we have to take derivatives of two functions and add them. Let us see this example. Y is equal to 2x square plus e to power x. Then y dash will be equal to derivative of this function will be like this. So the result is 4x plus derivative of this function e to power x. You know d by dx of e to power x is same as e to power x. So this is the answer. Let us see the subtraction. Y is equal to fx minus gx. Fx is one function, gx is another function. Then similarly, y dash x is equal to f dash x minus g dash x. Let us see this example. Y dash will be equal to derivative of this function will be 4x as we have already done minus ln x. So derivative of ln x, you remember from the previous table, it is 1 by x. So y dash will be 4x minus 1 by x. Third one, multiplication of two functions, also known as product rule. Y is equal to fx into gx. Fx is first function and gx is second function. Then y dash will be first function into derivative of second function plus second function into derivative of first function. Let us see this example. Y is equal to x sine x. So fx is equal to x, gx is equal to sine x. So y dash will be equal to first function x into derivative of second function d by dx of sine x plus second function sine x into derivative of first function d by dx of x. That will be equal to x into derivative of sine x will be cos x. X cos x plus sine x into derivative of x will be equal to 1. So the answer will be y dash is equal to x cos x plus sine x. Fourth one is division of two functions, also known as division rule. Y is equal to fx upon gx. Fx and gx are two functions. Then y dash is equal to gx into f dash x minus fx into g dash x divided by gx whole square. Let us see this example. Y is equal to cos x upon x. Here fx is equal to cos x and gx is equal to x. So y dash will be equal to gx into f dash x. Gx is x into f dash x will be d by dx of cos x minus fx into g dash x. Fx is cos x into g dash x can be written as d by dx of x divided by gx whole square x square. So it will be x into d by dx of cos x will be minus sin x minus cos x. D by dx of x will be 1 divided by x square. So the answer is minus x sin x minus cos x divided by x square. Fifth one, function of functions, also known as chain rule. Suppose there is a function y is equal to fx and another function x equal to ft. Then dy by dt is equal to dy by dx into dx by dt. dy by dx can be calculated from here and dx by dt can be calculated from here. Let us see this example. Y is equal to 4 sine 3x. Assume t is equal to 3x. Then dt by dx is equal to 3 times d by dx of x. And that is equal to 3 d by dx of x is 1. So dt by dx is equal to 3. We have to calculate dy by dx from here. So dy by dx is equal to dy by dt into dt by dx. We will calculate dy by dt from here. So it can be written as y is equal to 4 sine, and we have assumed t is equal to 3x. So sine t, 4 sine t. So dy by dt is equal to 4 into d by dt of sine t, and that is equal to d by dt of sine t is cos t. So we will substitute these two values, this value and this value here. Dy by dt, just we have calculated, that is equal to 4 cos t. In place of t, we will put back 3x. 4 cos 3x into dt by dx. dt by dx is 3 into 3. So 4 into 3, that is 12 cos 3x. That will be equal to y dash or dy by dx. Now let us see maxima and minima of a function. Consider a particle is moving along this curve in 2D Cartesian coordinate plane. At point A, it is at top, and at point B, it is at bottom. Point A is maxima and point B is minima. Draw a tangent at point A and another tangent at point B. They will be parallel to x-axis, means their slope will be 0. Their slope will be given by tan theta, where theta is the angle they make with the positive x-axis. In these cases, theta is 0 degree, so y dash, which is given by the slope of tangent, will be 0 in both the cases, maxima and minima. So in maxima and minima, dy by dx is equal to 0. Consider 2 points A1 and A2. A1 is at left of A and A2 is at right of A. Now draw tangents at A1 and A2. So tangent at A1 will have positive slope. At A it will have 0 slope, and at A2 it will have negative slope. Means rate of change of slope is decreasing from positive to 0, 0 to negative. So rate of change of slope is given by d by dx of dy by dx, where dy by dx is slope. So rate of change of slope, which is double derivative of y, means d square y upon dx square, will be negative in case of maxima. So for maxima, there are two conditions. Dy by dx is equal to 0 and d square y upon dx square is less than 0. Similarly, consider 2 points B1 and B2. B1 is at left of B and B2 is at right of B. Draw tangents at B1 and B2. Slope of tangent at B1 will be negative. At B it is 0 and at B2 it will be positive. Means rate of change of slope is going from negative to 0, 0 to positive. So it is increasing, and rate of change of slope is given by d by dx of dy by dx, which is nothing but double derivative of y, means d square y upon dx square. So in case of minima, d square y upon dx square is greater than 0. So you need to remember these conditions for maxima and minima. Now let us see integration. Integration is the reverse process of differentiation. By integration, we can find a function whose differentiation is known. This is integration sign. So integration of fx dx is equal to fx plus c. If you differentiate this part, you will get this function. Let us see few basic formula of integration. First one is integration of x to power n dx. That is equal to x to power n plus 1 upon n plus 1 plus c. C is constant of integration. Second one, integration of ax plus b to power n dx. That is equal to ax plus b to power n plus 1 upon a times n plus 1 plus c. Third one, integration of e to power x dx is e to power x plus c. Fourth one, integration of e to power ax plus b dx is equal to e to power ax plus b upon a plus c. Fifth one, integration of 1 by x dx is equal to ln x plus c. Sixth one, integration of 1 by ax plus b dx is ln ax plus b upon a plus c. Seventh one, integration of sin x dx is equal to minus cos x plus c. Eighth one, integration of sin ax plus b dx is equal to minus cos ax plus b upon a plus c. Ninth one, integration of cos x dx is equal to sin x plus c. 10th one, integration of cos ax plus b dx is equal to sin ax plus b upon a plus c. 11th one, integration of sec square x dx is equal to tan x plus c. And the last one, integration of sec square ax plus b dx is equal to tan ax plus b upon a plus c. You can note them down and memorize. The cross verification is, if you do the differentiation of right side, you will get this function. For example, sin x plus c. When you do differentiation of this, you will get cos x plus 0, means cos x. Now let us see some questions on integration. First one is integration of 2x to power 4 dx. That is equal to, we can take 2 out. So 2 integration of x to power 4 dx. And we know that integration of x to power n dx is equal to x to power n plus 1 upon n plus 1 plus c. So it is equal to 2. Here n is equal to 4. So it will be 2 into x to power 4 plus 1, means x to power 5 upon 5 plus c. So the answer is 2x to power 5 upon 5 plus c. Second question, integration of x plus 1 by x dx. So we can write it as integration of x dx plus integration of 1 by x dx. Integration of x dx can be figured out by this. Put n is equal to 1. So integration of x dx will be equal to x to power 1 plus 1 upon 1 plus 1, means x square by 2. So it will be x square by 2 plus. Integration of 1 by x dx is equal to ln x plus constant of integration. So integration of x plus 1 by x dx is equal to x square by 2 plus ln x plus c. Third question, integration of sine 2x plus 3 dx. We know the formula that integration of sine ax plus b dx is equal to minus cos ax plus b upon a plus c. Now putting the value a is equal to 2 and b is equal to 3. So integration of sine 2x plus 3 dx will be equal to minus cos 2x plus 3 upon 2 plus c. Now let us see definite integration. When a function is integrated between a lower limit and an upper limit, it is called as definite integration. It is represented as integration sign. This is lower limit, this is upper limit. Fx dx is equal to fb minus fa. Let us see one example. Integration of 3x square dx between x equal to 1 and x equal to 3. We know that integration of x to power n dx is equal to x to power n plus 1 upon n plus 1 plus c. So we can write it as 3 integration of x square dx between 1 to 3. So it will be equal to integration of x square dx will be, put n is equal to 2. So x to power 3 upon 3. X to power 3 upon 3 plus c. Now put the limits 1 to 3. So we can evaluate this as, put the upper limit first. So x equal to 3. So 3 cube will be 27. 27 upon 3 will be 9. So it will be 9 plus c. Minus lower limit, put x equal to 1. So it will be 1 by 3 plus c. 1 by 3 plus c. So it will be equal to 3 into 9 plus c minus 1 by 3 minus c. So c plus c and minus c will get cancelled out. So it will be 9 minus 1 by 3. So it will be equal to, take 3 as LCM, 3 9s are 27 minus 1. So it will be 3 into 26 upon 3. and that will be 26. Now let us see area under a curve and x-axis. Consider this curve is given by y is equal to fx. We have to find out area between this curve and x-axis between the limits x equal to a and x equal to b, means this area. Consider a very small strip of width dx and height y. So area of the strip will be given by dA is equal to y into dx, considering it as a rectangle of very small width and height y. So area will be given by integration of dA between the limits x equal to a and x equal to b. So we can write it as area is equal to a to b, dA can be replaced by y dx. Average value of a continuous function in an interval. Consider the function y is equal to fx and interval is x lies between a to b. So the lower limit is a and upper limit is b. So average value of y is given by the formula integration of y dx between limits a and b upon integration of dx between limits a and b. So it will be equal to integration of y dx between limit a and b, and this will be equal to b minus a. How? Because integration of dx means integration of 1 dx, that will be equal to x, and when you put the limit, so it will be higher limit b minus lower limit a, so its value will be b minus a. That's what it is written here. So average value can be calculated by this formula. Let us see this example. Determine the average value of y is equal to x plus 4 in the interval x lies between 0 to 2. So y average is equal to integration of y dx, means x plus 4 dx between the limits 0 to 2, divide by b minus a, means 2 minus 0. So it will be integration of x plus 4 dx will be x square by 2 plus 4x plus c. Now put the limits 0 to 2 divided by 2. So when you put x equal to 2, it will be 2 square. 4 upon 2 means 2 plus 4 into 2 means 8. So 2 plus 8 plus c. Minus, when you put lower limits, it will be 0 plus 0 plus c, that is equal to c divided by 2, means 2 plus 8, 10 plus c minus c divided by 2, that is 10 by 2 equal to 5. We are starting kinematics today. There are two chapters in it. First, this one, motion in a straight line, and the second, next one, motion in a plane. So what is kinematics? Kinematics is the branch of mechanics which deals with the motion of the objects without a reference to the forces that cause the motion. Means in kinematics, we will talk only about the motion of the objects, not the forces which cause the motion. When an object does not change its position as the time passes, we say that the object is at rest. And when the object changes its position as the time passes, we say that the object is in motion. However, there is nothing is in absolute rest or in absolute motion state. Everything depends on the reference frame. To understand the reference frame, let us see this example. Suppose a train is moving next to a platform. A person who is sitting inside the train will see its ceiling fan at rest. On the other hand, the person who is standing at the platform will see the ceiling fan as well as the other person moving. So we cannot say that the ceiling fan is at rest or in motion. The precise statement will be ceiling fan is at rest with respect to the train and ceiling fan is moving with respect to the ground or platform. Suppose there is a particle at point P. To locate this particle, we need a reference frame. A convenient reference frame will be three mutually perpendicular axes x, y and z in 3D Cartesian coordinate plane. Coordinates of this point will give the location of the particle. Now add a clock to this reference frame to measure time. As the time passes, if the coordinates of this point do not change, then the particle is at rest. If the coordinates means any of the coordinates x, y, z changes, then we say that the particle is in motion. Here onwards, we will assume that the reference frame is already chosen and the particle is moving with respect to the chosen reference frame. Now let us see translational motion. Translational motion can be defined as the motion in which all points of the moving body move uniformly either in same line or in same direction. Translational motion can be divided into two categories, rectilinear motion and curvilinear motion. In rectilinear motion, object moves in a straight line, means motion in 1D. Curvilinear motion can be divided into two categories, motion in 2 dimension or motion in 3 dimension, means motion in a plane or motion in a space. Now let us understand these terms. Distance, displacement, displacement vector, uniform speed or constant speed, non-uniform speed or variable speed, average speed, and instantaneous speed. Suppose a particle is moving along this curve. This is our reference frame. Time taken by the particle is shown on the x-axis and distance it travels is shown on the y-axis. At a certain time t is equal to t1, it was at point A on the curve, and at t is equal to t2, it was at B on the curve. Then the distance it travelled between A to B is given by the length of this curved path. Displacement. Minimum distance between points A and B is called displacement. It is given by magnitude of this called AB. Displacement vector. Displacement is a vector quantity. Its direction is from start point to end point. So this is direction. Uniform speed or constant speed. Suppose the particle travels from point A to B on this curve at a certain speed. Its speed doesn't change. Then it is said to be uniform speed or constant speed. Non-uniform speed or variable speed. It is possible that during the journey, speed was changing. For example, suppose speed was v1 for a duration of delta t1, v2 for a duration of delta t2, and so on. Average speed calculation. Average speed can be calculated by the formula v is equal to, v average is equal to total distance traveled, let's say delta s, upon total time taken delta t. If the speed was uniform, this is the formula. If the speed was varying, then the formula will be v average is equal to v1 delta t1 plus v2 delta t2 plus and so on up to vn delta tn divided by total time taken delta t1 plus delta t2 plus and so on up to delta tn, and this is nothing but delta t. So the formula will be v average is equal to v1 delta t1 plus v2 delta t2 plus and so on up to vn delta tn upon delta t. Last one is instantaneous speed. Average speed is calculated for a duration of time and instantaneous speed is calculated at a certain point of time. Suppose we have to calculate instantaneous speed at point P, then delta t has to be very small, means delta t tends to 0. So instantaneous speed will be equal to delta s upon delta t when delta t tends to 0. And this is equal to ds by dt. ds by dt is nothing but the slope of tangent at point P. Let us see these questions. First question, Arvind runs on a circular track of radius 14 meter. If he starts at one point and reaches at the same point, calculate the distance traveled and displacement. So this is a circular track. Let's say this is center O and this is one point A where Arvind starts running. This is 14 meter. So Arvind takes a round and comes back at the same point. So distance traveled will be given by the length of this circular path. and the length of the circular path means circumference will be equal to 2 pi into radius. Radius is 14. So it will be equal to 2 into 22 by 7 into 14. So 7 ones are 7, 7 twos are 14. 2 into 2 is 4 into 22, that is 88 meter. And the displacement we have to calculate. You know that the displacement is minimum distance between start point and end point. Since start and end points are same, so the displacement will be 0. Second question, a man walks at a speed of 4 km per hour for 1 km and 6 km per hour for next 1 km. What is his average speed for the walk of 2 km? So the average speed V average is equal to total distance traveled, that is 2 km, upon total time taken, that is T1 plus T2. We have to calculate T1 and T2. So T1 is equal to distance traveled 1 km upon speed. So that is 1 upon 4 hours. And T2 is equal to distance traveled 1 km upon speed 6 km per hour. So this is 1 upon 6 hours. T1 plus T2 is equal to 1 by 4 plus 1 by 6. LCM is 12, 4 3s are 12 plus 6 2s are 12, that is 5 by 12 hours. Now V average is equal to 2 upon 5 by 12, and that is equal to 2 into 12 upon 1 into 5, that is equal to 24 upon 5, and that is equal to 4.8 km per hour. Third question, the distance traveled by a particle in time t is given by s is equal to 2t square meter. Find its instantaneous speed at t is equal to 3 seconds. So instantaneous speed vi is equal to ds upon dt. That is equal to d upon dt of s is given as 2t square. We will take 2 out. So it will be 2 d by dt of t square. D by dt of t square is 2t. So it will be equal to 2 into 2t, and that is equal to 4t. So instantaneous speed is given by 4t. We have to calculate instantaneous speed at t is equal to 3. So put t is equal to 3. So Vi at 3 will be equal to 4 into 3. That is 12 meter per second. Now let us understand these terms: position vector, average velocity and instantaneous velocity. Consider a particle is moving along this curve PQR. This is the reference frame. Time taken is shown on the x-axis and position of the particle is shown on the y-axis. At t is equal to t1, particle was at point A, and at t is equal to t2, particle was at point B. Then the position vector when the particle was at A is given by OA. Let's say it is R1. And the position vector when the particle was at B is given by OB. Let's say it is R2. Then the displacement vector AB is equal to vector R2 minus vector R1. And the average velocity will be given by V average is equal to R2 minus R1 divided by T2 minus T1, and it is equal to delta R upon delta T. Instantaneous velocity. Suppose we have to calculate instantaneous velocity at point Q. Then this time interval has to shrink, means delta T should tend to 0. Then instantaneous velocity Vi is equal to delta R upon delta t, limit delta t tends to 0, and that is equal to dr upon dt. Now let us see these terms: average acceleration and instantaneous acceleration. Suppose the particle is having velocity v1 at t is equal to t1 and v2 at t is equal to t2. Then the average acceleration between t1 to t2 is given as v2 minus v1 upon t2 minus t1, and that is equal to delta v upon delta t. Instantaneous acceleration is given by delta v upon delta t when delta t tends to 0, and that is equal to dv upon dt. Now let us see motion in a straight line. First point is convention for positive and negative. If a particle is moving towards right or upwards, its direction of motion is supposed to be positive. Similarly, if it is moving towards left or downwards, its direction of motion is supposed to be negative. Second point, convention for motion. Generally, it is considered that particle is at origin at t is equal to 0, and then it starts moving along the positive x-axis. Third point, v is equal to dx by dt if the particle is moving along the x-axis, and a is equal to dv upon dt, which in turn is equal to d square x upon dt square. Similarly, integration of dx is equal to integration of v dt, and integration of dv is equal to integration of a dt. Let us consider these 2 points separately. Suppose we want a relation between x, v and a, that is position, velocity and acceleration. If we have to calculate the next quantity when the previous is given, then we have to differentiate. Suppose we want to get v when x is given, then we need to differentiate x with respect to time. Means v is equal to dx upon dt and a is equal to dv upon dt. If we have to move in opposite direction, then we need to integrate. Means to calculate v when a is given, v is equal to integration of a dt. To calculate x when v is given, x is equal to integration of v dt. Last point, direction of position, velocity and acceleration vectors. Consider a particle is moving in the positive x direction. Then its position vector and velocity vector will be in the same direction. Direction of acceleration vector will depend on whether the particle's velocity is increasing or decreasing. If it is increasing, then acceleration vector will also be in the same direction. But if particle's velocity is decreasing, then acceleration vector will be in opposite direction, means negative acceleration or retardation. Now let us consider motion with constant acceleration. Suppose a particle is moving with constant acceleration a. Then we can write dv upon dt is equal to a. That means rate of change of velocity is equal to acceleration. From here we can write dv is equal to a dt. Now integrating both the sides within limits. Initial velocity is v0 and final velocity is v. Initial time t is equal to 0 and final time t is equal to t. So we get this equation, v is equal to v0 plus at. This is first equation of motion in a straight line. Now write dx upon dt in place of v. So dx upon dt is equal to v0 plus at, or dx is equal to v0 plus at into dt. Now integrate both the sides within limits. Initial position is x0, final position is x. So we get this equation, x equal to x0 plus v0t plus half at square. This is second equation of motion in a straight line. Now square both the sides of first equation. So we get v square is equal to v0 plus at whole square. We can expand this as v0 square plus 2v0 at plus a square t square, or v0 square plus take 2a common in both terms. So we will get v0t plus half at square in bracket. Now replace v0t plus half at square as x minus x0. So we get this equation, v square equal to v0 square plus 2a x minus x0. This is third equation of motion in a straight line. You need to keep in mind these three equations of motion in a straight line. Just now we have seen that there are three equations of motion in a straight line with constant acceleration, and they are v is equal to v0 plus at, x equal to x0 plus v0t plus half at square, and v square is equal to v0 square plus 2a x minus x0. Now let us see equations of motion for free falling bodies near the Earth's surface. We know that the acceleration due to gravity works in the downward direction, and downward is supposed to be negative direction. So replace A with minus g. So the equations of motion for free falling bodies near the Earth's surface will be v is equal to v0 minus gt, x equal to x0 plus v0t minus half gt square, and v square is equal to v0 square minus 2g x minus x0. Let us see this question. Position of a particle x as a function of time t is given by x is equal to 2t square plus 3t plus 4. Find the velocity and acceleration of the particle when t is equal to 1 second. Means it is asking for instantaneous velocity and instantaneous acceleration. So instantaneous velocity vi is equal to dx upon dt. That is equal to d upon dt of x is given as 2t square plus 3t plus 4. So this will be equal to differentiation of this whole with respect to t is equal to 2 into 2t plus 3. That is equal to 4t plus 3. So instantaneous velocity is 4t plus 3. At time t is equal to 1 second, instantaneous velocity at 1 second will be equal to 4 into 1 plus 3, and that is equal to 4 into 1 is 4 plus 3 means 7 meter per second. Instantaneous acceleration. So instantaneous acceleration ai is equal to d by dt of vi. So that is equal to d by dt of vi we have calculated as 4t plus 3. That will come out to be 4. So instantaneous acceleration is constant throughout. So at t is equal to 1 second, it will be 4 meter per second square. Second question, a car starts moving with an acceleration 2 meter per second square for 10 seconds. Then it decelerates with 1 meter per second square. Find the total distance traveled by the car till it stops. Suppose car starts at A. It travels till B with acceleration 2 meter per second square and takes time t1, which is 10 seconds. From B to C, it decelerates at 1 meter per second square and takes time t2. Finally, at C, it stops. Its velocity at B is vb and at C it is vc. Vc is equal to 0. For section AB, v0 is equal to 0 because car was at rest at point A. A1 is equal to 2 meter per second square given. T1 is equal to 10 seconds given. So Vb is equal to V0 plus A1 T1. So Vb is equal to 0 plus 2 into 10. So Vb comes out to be 20 meter per second. Another formula, Vb square is equal to V0 square plus 2A into x minus x0, and x0 is equal to 0. So 20 square is equal to 0 plus 2 into A. A is 2 into x. So x comes out to be 100 meter. Means distance between A to B is 100 meters. Now for section B to C, Vc square is equal to Vb square plus 2A2 into x minus x0. For this section, x0 is 100 meters. So we will put x0 is equal to 100. Vc is equal to 0 because car finally stops. So 0 is equal to 20 square. Vb is 20, we have already calculated. So 20 square plus 2 into A2. A2 is equal to minus 1 because it decelerates. X minus 100. So x comes out to be 300 meter, which is the total distance between A to C. So the car travels 300 meters between A to C. Third question, a ball is dropped from a tower. In the last second of its motion, it travels a distance of 15 meters. Find the height of the tower given g is equal to 10 meters per second square. Suppose AC is the tower. Its height is h. It takes t seconds for the ball to start from A and reach at C. So total journey time is t seconds. It is given that in last 1 second it travels 15 meter, means length of section AB is h minus 15, and it takes t minus 1 second to travel the distance AB. So now we will start forming the equations. For section AC, x equal to x0 plus u0t minus half gt square. Since ball is starting at A and going down, so x is equal to minus h. Minus h is equal to x0 is 0. Ball is starting from here. So x0 is 0 plus initial velocity u0 is also 0. Minus 1 by 2, g is given as 10 t square. So t square is equal to h upon 5. This is first equation. Now consider section AB. So applying the same equation again, minus h minus 15 is equal to 0 plus 0 minus 1 by 2 g into time is t minus 1 second for section AB. So t minus 1 whole square. So t minus 1 whole square is equal to h minus 15 upon 5. Now subtracting equation 2 from equation 1, it will be t square minus t minus 1 whole square is equal to h upon 5 minus h minus 15 upon 5. So t comes out to be 2 seconds, means total time of journey is 2 seconds. Put t is equal to 2 here in this equation. So 2 square is equal to 4 is equal to h by 5. So h comes out to be 20 meters, means the height of the tower is 20 meters. Now let us see motion with variable acceleration. When acceleration is a function of time, when acceleration is a function of position, and when acceleration is a function of velocity. Let us understand these with the help of this question. Find the formula for velocity v when acceleration a is given by a is equal to t plus 2, a is equal to 2x, and a is equal to 2v. Here acceleration is a function of time, here acceleration is a function of position, and here acceleration is a function of velocity. First part, we know that dv by dt is equal to a, means dv is equal to a dt. You need to remember this formula. Now integrating both the sides of it within limits. So integration of dv within limits v0 to v is equal to integration of a dt. A is given as t plus 2. So integration of t plus 2 dt within limits 0 to t. So v within limits v0 to v is equal to t square by 2 plus 2t within limits 0 to t. That means v is equal to v0 plus t square by 2 plus 2t. Second part, we know that a is equal to dv by dt and v is equal to dx by dt. So a upon v is equal to dv upon dx. Cross multiply v dv is equal to a dx. You need to remember this formula as well. Now integrate both the sides within limits. So integration of v dv within limits v0 to v is equal to integration of a is given as 2x. So integration of 2x dx within limits x0 to x. So that will give v square is equal to v0 square plus 2 times of x square minus x0 square, or v is equal to plus minus under root v0 square plus 2 times of x square minus x0 square. Third part, we know that dv is equal to a dt. So dv is equal to, put the value of a from here, 2v dt. Bring v on this side. So 1 upon v dv is equal to 2 dt. Now integrate both the sides within limits. Integration of 1 upon v dv within limits v0 to v is equal to integration of 2 dt within limits 0 to t. Integration of 1 upon v dv is equal to log v, that is natural log. Log v within limits v0 to v is equal to 2t. Now on the left hand side, we can write log v minus log v0, that is equal to 2t. Log m minus log n is log m upon n, means log v upon v0 on the base e is equal to 2t, or v upon v0 is equal to e to power 2t. So v is equal to v0 e to power 2t. Now let us see graphs. Xt graph, vt graph and at graph, means position time graph, velocity time graph and acceleration time graph when velocity is 0, when velocity is constant, when velocity is uniformly increasing, and when velocity is uniformly decreasing. Xt graph when v is equal to 0 will be a straight line parallel to x-axis. And when v is equal to 0, velocity is 0, it will be a point. And acceleration is also 0, it will be a point. When v is equal to constant, xt graph will be like this, slanting line. and VT graph will be like this, a straight line parallel to x-axis, and AT graph will be a point. When V is uniformly increasing, it will be parabolic. XT graph will be parabolic, and VT graph will be a straight line, slanting line, and AT graph will be, this curve will be parallel to x-axis. V is uniformly increasing, means XT graph will be like this, and VT graph will be slanting like this, and AT graph, in this case, A will be negative, means retardation. Let us see XT graph, VT graph and AT graph for uniformly accelerated motion and uniformly decelerated motion. XT graph will be like this for uniformly accelerated motion, VT graph will be like this, and AT graph will be like this parallel to x-axis. For uniformly decelerated motion, XT graph will be like this, VT graph will be like this, and AT graph will be like this. It is on the negative side because it is decelerated motion, so acceleration will be negative. Now let us see previous year's JEE questions. First question, the relation between time t and distance x for a moving body is given as t is equal to mx square plus nx, where m and n are constants. The retardation of the motion is when v stands for velocity. These are the options given. This question appeared in JEE Mains 2021. We know that dx by dt is equal to v and d square x upon dt square is equal to a. So in order to get acceleration, that is d square x upon dt square, we need to double differentiate the given relation with respect to time. So let us start. D by dt of t is equal to d by dt of mx square plus nx. dt upon dt is equal to 1. We can open the bracket using distributive property. So it will be m into d by dt of x square plus n into d by dt of x. So 1 is equal to m into d by dt of x square will be 2x dx by dt plus n into dx by dt. Put v in place of dx by dt, as we know that dx by dt is equal to v. So the equation will be 1 equal to m into 2x into v plus n into v. Take nv to this side. So 1 minus nv is equal to 2mvx, or x equal to 1 minus nv upon 2mv. This is our equation number 2. Now differentiate equation 1 again with respect to time in order to get d square x upon dt square. So d by dt of 1 is equal to d by dt of this whole stuff. So d by dt of constant is equal to 0 is equal to, now use distributive property again to open this bracket. So it will be 2m d by dt of x into dx by dt plus n into d by dt of dx by dt. So it will be 2m into d by dt of this can be done using chain rule. Suppose x is first function and dx by dt is second function. So it will be first function into differential of second function d by dt of dx by dt plus second function into differential of first function, means d by dt of x, plus n into d by dt of dx by dt is d square x upon dt square. So it will be 0 is equal to 2m x into d by dt of dx by dt is d square x upon dt square plus dx by dt into dx by dt, that is dx by dt whole square, plus n into d square x upon dt square. Now replace dx by dt by v and d square x upon dt square by a. So it will become 0 is equal to 2m x into a plus v square plus n into a. Now replace x by this 1 minus nv upon 2mv. So 1 minus nv upon 2mv into a plus v square plus na. Now take LCM as 2mv inside the bracket. So it will be a into 1 minus nv plus 2mv into v square, means 2mv cube. Now cancel out 2m and 2m here. So it will be a into 1 minus nv plus 2mv cube upon v plus na. Now take LCM as V of this whole. So it will become 0 is equal to A into 1 minus NV. When you open the bracket, it will be A minus ANV plus 2NV cube plus ANV. Now plus A and B minus A and B will get cancelled out. So it will become A plus 2mb cube is equal to 0, or A is equal to minus 2mb cube. Negative sign shows retardation. So A will be equal to 2mb cube, and the correct option will be option A. Second question, a helicopter rises from rest on the ground vertically upwards with a constant acceleration g. A food packet is dropped from the helicopter when it is at a height h. The time taken by the packet to reach the ground is close to g is the acceleration due to gravity. These are the options given. This question appeared in JEE Mains 2020. Suppose the helicopter starts from the ground at t is equal to 0. So v0 is equal to 0 and x0 is also 0. When it reaches a height h, it drops a food packet. So we have to calculate how much time food packet will take to reach the ground. So let us start. First we will calculate the velocity, means initial velocity of the food packet when it was dropped. So v square is equal to v0 square plus 2a into x minus x0. Here v0 is 0 and x0 is 0 when the helicopter is starting. So v square is equal to v0 square plus 2 into a. A is given as g. So it will be 2 into g into h minus 0. So v square is equal to 0 plus 2gh, means v is equal to under root 2gh. So this is our first equation. Now we will use x equal to x0 plus v0t plus half at square. This formula to calculate the time taken by the food packet to reach the ground. X equal to, now this is our reference point. So x equal to minus h, because food packet is coming down. So minus h is equal to, now x0 is 0. Food packet is starting from here. And v0 is equal to v. We have just calculated and its direction was upwards. So it will be taken as positive. So v into t plus half into a. Acceleration will be now minus g. So minus half gt square. So minus h is equal to 2vt minus gt square upon 2, or minus 2h is equal to 2vt minus gt square. So gt square minus 2vt minus 2h is equal to 0. So we will get a quadratic in t. So value of t will be given by minus b plus minus under root b square minus 4ac upon 2a. So we will get two values of t. Negative we cannot take because the time calculated will be negative in that case. So t comes out to be approximately 3.4 under root h by g. So the correct option is option C. Third question, a balloon was moving upwards with a uniform velocity of 10 meter per second. An object of finite mass is dropped from the balloon when it was at a height of 75 meter from the ground level. The height of the balloon from the ground when object strikes the ground was around g is equal to 10 meter per second square. These are the options given. This question appeared in JEE Mains 2021. Suppose the balloon was at point A on the ground. Now it starts rising. When it reaches point B, which is 75 meters above the ground, an object was dropped from it. Now the object reaches the ground and balloon keeps on rising. So we have to calculate this distance AC that the balloon reaches when the object reaches the ground. So we have to calculate AC. Let us start. X equal to x0 plus v0t plus half at square. We will calculate the time the object takes in reaching the ground from this formula. Now this is our reference point. Object is coming down, so x is minus 75. Initially there was no displacement, so x0 is 0. v0 is equal to v, velocity of the balloon. Since the balloon is going up, so velocity will be taken as positive, means initial velocity of the object will be taken as positive, that is 10, into t, time taken by the object to reach the ground, plus 1 by 2, a is minus g, means object is coming down, so g will be taken as 10. So it will be minus 75 is equal to 0 plus 10t plus 1 by 2 into minus 10t square. It will be minus 75 is equal to 10t minus 5t square. Now divide this whole equation by 5. So it will be minus 15 is equal to 2t minus t square. Now change the sides. So it will be t square minus 2t minus 15 is equal to 0. Now its two factors will be minus 5 and plus 3. So t minus 5 into t plus 3 is equal to 0. So time will come out to be plus 5 or minus 3. Time cannot be negative, so minus 3 can be neglected. So t is equal to 5 seconds, means object will take 5 seconds to reach the ground. In 5 seconds, how much high the balloon will be? So h will be equal to 10 into 5. Velocity of the balloon is given as 10 meter per second, which is constant. So 10 into 5 means 50 meter. Means balloon will go further 50 meter up. So we have to calculate AC. AC will be 75 plus 50. That will be 125 meter. So the correct option will be option C. Fourth question, starting from the origin at time t is equal to 0 with initial velocity 5j meter per second, a particle moves in xy plane with a constant acceleration of 10I plus 4j meter per second square. At time t, its coordinates are 20 meter and y0 meter. The value of t and y0 are respectively. These are the options given. This question appeared in JEE Mains 2020. So we will use this formula x equal to x0 plus v0t plus half at square to figure out coordinates of the particle at any time t. So x equal to x0 is 0 at t is equal to 0. So x0 is 0. v0 is given as 5j. So 5jt plus 1 by 2. A is given as 10I plus 4j. So 10I plus 4j t square. So x equal to 5jt plus 5t square I plus 2t square j when you solve this. So x equal to 5t square I plus 5t plus 2t square j when you rearrange the terms. Now these show the coordinates of the particle, means x coordinate, y coordinate at any point of time t. So we can equate 5t square with 20 and 5t plus 2t square with y0. So when you equate 5t square with 20, you get t is equal to 2 seconds. Now put t is equal to 2 seconds in when you equate y0 with 5t plus 2t square. So you get y0 is equal to 18 meter. So the answer will be, they are asking for the value of t and y0. It will be 2 seconds and 18 meter. So the correct option will be option C. Fifth question, a particle starts from the origin at t is equal to 0 with an initial velocity of 3I meter per second and moves in the xy plane with a constant acceleration 6I plus 4j meter per second square. The x coordinate of the particle at the instant when its y coordinate is 32 meter is d meters. The value of d is. These are the options given. This question appeared in JEE Mains 2020. This looks very similar to the question we have just solved. So let us use the formula x equal to x0 plus v0t plus half at square. So x equal to x0 is 0 at t is equal to 0. So it is 0 plus v0 is given as 3i. So 3it plus 1 by 2, a is given as 6i plus 4j. 6i plus 4j t square. So x equal to 3it plus 3t square I plus 2t square j when you simplify this. So x equal to 3t plus 3t square I plus 2t square j when you rearrange the terms. Now equate y coordinate with 32. So 2t square is equal to 32. So t comes out to be 4 seconds. To know the x coordinate, you need to put the value of t in this 3t plus 3t square. So put t is equal to 4, you will get the x coordinate as 60, means d is 60. So the correct option is option C. Sixth question, a particle is moving with a speed v is equal to b root x along positive x-axis. Calculate the speed of the particle at time t is equal to tau. Assume that the particle is at origin at t is equal to 0. These are the options given. This question appeared in JEE Mains 2019. It is given that v is equal to b under root x. We can write dx by dt is equal to b under root x as v is equal to dx by dt. Also we can write dx upon root x is equal to b dt. Now we can multiply both numerator and denominator by 2. So it is 2 dx upon 2 root x is equal to b dt. Now integrate both the sides within limits. So integration of 2 dx upon 2 root x within limits 0 to x is equal to integration of b dt within limits 0 to t. Take 2 out. So integration of 1 upon 2 root x dx within limits 0 to x is equal to integration of b dt within limits 0 to t. So we can say 2 integration of 1 upon 2 root x dx is equal to root x within limits 0 to x, that is equal to b taken out t within limits 0 to t. So 2 under root x is equal to bt or under root x is equal to bt upon 2. This is our second equation. Now from equation 1, dx by dt is equal to b under root x. Put the value of under root x from here. So dx by dt will be equal to b into bt by 2. That will be b square by 2, t is equal to tau. T is equal to tau. So v will be equal to b square tau upon 2. So the correct option will be option B. Seventh question, water drops are falling from a nozzle of a shower onto the floor from a height of 9.8 meter. The drops fall at a regular interval of time. When the first drop strikes the floor, at that instant, the third drop begins to fall. Locate the position of second drop from the floor when the first drop strikes the floor. These are the options given. This question appeared in JEE Mains 2021. So let us understand the question first. In this figure, drop 1 is here and drop 2 has just come out. Let us say time difference between them is t. In second figure, drop 1 has reached the floor. Drop 2 is here, drop 3 is here. Time difference between them will be same as it is given the drops fall at a regular interval of time. But the distance they travel will not be same as they are under accelerated motion. This height is given as 9.8 meter. We have to calculate this height. So let us consider this section first. We will use this formula x is equal to x0 plus v0t minus half gt square. This is our reference point. Since drops are falling down, so x will be negative. Minus 9.8 is equal to x0 is 0, v0 is 0 minus 1 by 2 g. Now time will be t plus t means 2t whole square. So t square will be equal to 9.8 upon 2g. This is our first equation. Now consider this section. We will use same formula again. X equal to x0 plus v0t minus 1 by 2 gt square. In this case, x will be this 9.8 minus h. So this will be minus 9.8 minus h is equal to 0 plus 0 minus 1 by 2g and t square. So it will be minus 9.8 minus h is equal to 1 minus 1 by 2 g t square. Now value of t square can be substituted from equation 1. T square is equal to 9.8 upon 2g. So h comes out to be 7.35 meter. So the correct option is option D. Eighth question, the velocity displacement graph of a particle is shown in the figure. This is the figure. The acceleration displacement graph of the same particle is represented by. These are the options. This question appeared in JEE Mains 2021. So the equation of this line can be given by y is equal to mx plus c, where m is slope of this line. Slope of this line will be negative as it is making more than 90 degree with the positive x-axis, and magnitude of the slope will be v0 upon x0. On the y-axis is v, on the x-axis is x. So in place of y, v will be written and slope is minus v0 upon x0, x plus c is the y-intercept, that will be v0. So equation of line will be v is equal to minus v0 upon x0, x plus v0. Now differentiate both the sides with respect to time. So d by dt of v is equal to d by dt of this whole stuff. That will be d by dt of minus v0 upon x0 x plus d by dt of v0. dv by dt is equal to, this is constant, so it will be taken out, minus v0 upon x0 dx upon dt plus d by dt of constant will be 0. Now dv by dt is equal to a and dx by dt is equal to v. So it will be equal to a is equal to minus v0 upon x0 v. So a is equal to minus v0 upon x0. In place of v, we can write this. So that is equal to minus v0 upon x0 x plus v0. So a is equal to, now multiply this with both these terms. So it will be v0 square upon x0 square x minus v0 square upon x0. So ax equation also can be written in the form y is equal to mx plus c, where m is v0 square upon x0 square, means this line must be having positive gradient, means positive slope. So among these lines, which line has positive slope? This line has zero slope, this line has zero slope, and this line has negative slope. Only this line has positive slope. So this is the correct option. Ninth question, a mosquito is moving with a velocity v is equal to 0.5 t square I plus 3 tj plus 9k meter per second and accelerating in uniform conditions. What will be the direction of mosquito after 2 seconds? These are the options given. This question appeared in JEE Mains 2021. It is given that v is equal to 0.5 t square I plus 3 tj plus 9k. Differentiating both the sides with respect to time, dv by dt is equal to d by dt of this whole, and that is equal to 0.5 into d by dt of t square is 2t I plus 3 d by dt of t is equal to 1 j plus d by dt of this constant is equal to 0. dv by dt is equal to a. So a is equal to 0.5 into 2, that is equal to 1 into t, means ti plus 3j. So assume this is the acceleration vector and this is 2D Cartesian coordinate plane. It is making theta angle with the positive x-axis. So in this right angle triangle, this will be ti and this will be 3j. So tan theta is equal to 3 upon t. T is given as 2. So tan theta is equal to 3 upon 2, means theta is equal to tan inverse 3 by 2 from x-axis. Let us see any option. No. So we need to check from the y-axis. Suppose this acceleration vector is making alpha with the y-axis. Then tan alpha in this right angle triangle will be t upon 3. Tan alpha will be t upon 3. Put value of t is equal to 2. So alpha is tan inverse 2 by 3 from y-axis. Tan inverse 2 by 3 from y-axis. So option B is correct. Last question, water droplets are coming from an open tap at a particular rate. The spacing between a droplet observed at 4 seconds after its fall to the next droplet is 34.3 meter. At what rate the droplets are coming from the tap? You can take G is equal to 9.8 meter per second square. These are the options given. This question appeared in JEE Mains 2021. So let us understand the question first. It is given that when the droplet 1 is here, it is 4 seconds from the start, and distance between two droplets, two consecutive droplets is 34.3 meter. Consider this height is h. We have to find out the time difference between two consecutive droplets. So assume this height is h. This is given as 34.3 meter. So this is h minus 34.3. We will consider this section first. This is the reference point. You're using this formula, x is equal to x0 plus v0t minus half gt square. So x is equal to minus h as the droplet is coming down. So x is minus h, x0 is 0, v0 is 0, minus 1 by 2 g into t. T is given as 4 seconds, so 4 square. H comes out to be equal to 8g. This is first equation. Again, consider this section. Using the same formula, x equal to x0 plus v0t minus 1 by 2 gt square. X is equal to, in this case, minus h minus 34.3 is equal to x0 is 0, v0 is 0, minus 1 by 2 g t square. So h minus 34.3 is half gt square, or 2 into h minus 34.3 is equal to gt square, or t square is equal to 2 into h minus 34.3 upon g, or t square is equal to 2 into h is equal to 8g from equation 1. So 8g minus 34.3 upon g, or t square is equal to 2 into 8 into g value can be put as 9.8. So 9.8 minus 34.3 upon 9.8. So t square comes out to be equal to 9. T is equal to 3 seconds. Means this duration is 3 seconds. So this duration is given as 4 seconds, and this duration we have figured out is equal to 3 seconds. Means duration between 1 and 2 is equal to 1 second. Means after 1 second the drop second comes out. It means it is 1 drop per second. That is the answer. In next video we will start motion in a plane. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.